For question A, we need to construct influence lines for vertical direction at A and B. So first, we must allow one unit load to move over the beam from left to right, like this. This direction A, RB, and allow one unit load kilometer. So this is distance X. So find the value of shear force like this. F upward equal to F downward. So RA plus RB equal to 1. This is equation number 1. Okay, next, moment at A equal to 0. So 1 times X equal to RB times 16 over equal to 0. So RB equal to X over 16. So from here we can, from equation of RB, substitute the value of 0 meter to 60 meter in the table. So like this, 0, 4, X, 12 and 16 meter. We can calculate the RB from this equation. So we will get 0, 0.25, 0.5, 0.75 and 1. So this is the influence lines. 0, 0.25, 0.5, 0.75 and this is 1. A, B, and here have C. It will be like this, 1 plus 3 over 4. So this is influence line for RB. Next, from the equation 1 and RB, we can find the support reaction at A like this. RA plus RB equal to 1. RA plus X per 16 equal to 1. So RA equal to 1 minus X per 16. So we can, from this equation, we can substitute value of 0 meter to 60 meter in table. 0 for 8, 12 and 16. Then we can calculate. We will get 0, 0.2, 1, 0.25, 0.5, 0.25 and 0. We can draw like this. 1, 0.75, 0.5, 0.25 and 0. This A, B and C will get like this. This here is negative 3 per 4. So this is influence line for RB, for RA.
For equation B, if point X located 4 meter from A, determine the shear Vx and moment Mx by using of section. So to find the Vx, we assume this is RA 4 meter and this is Vx and this one Mx. We assume point load 1 kilonewton at this point, and this is, we assume this one X and this one 4 minus X. Okay, to find the value Vx, Fy upwards equal to Fy downwards. Ra equal to 1 plus Vx. Then Ra equal to 1 minus x over 16 equal to 1 plus vx. Then we got vx equal to negative x over 16. Then to find the value vx, we assume x we assume x x we assume x meter and 4 meter. So when by using this equation vx negative x over 16, when x equal to 0, we got vx equal to 0. Then when x equal to 4, then we got vx equal to negative 0.25. Okay, for the moment by using the moment equation, moment at x equal to 0, so we got RA times 4, RA equal to 1 minus x over 16 times 4 minus 1 kilonewton times 4 minus x minus mx equal to 0. So we got mx equal to 3 over 4 x. Then to get the value moment mx, we assume again x equal to between 0 meter and 4 meter. So by using this question, mx 3 over 4x, so when x equal to 0, then mx we got 0. When x equal to 4 meter, then we got the value mx is 3. Okay, this is one for x. This is one we assume x equal to 0, x equal between 0 and 4. Then one more, we assume x equal to when x equal between 4 meter and 16 meter, we'll find vx. This is 4 meter, this is vx, and x 1 kilonewton, x 4 minus x. Okay, Fy upwards equal to Fy downwards, Ra equal to Vx, and Vx we got 1 minus x over 16. So by using this equation vx, this one from left section, then and this one from right section. Okay, continue with this equation to find the value Vx. We assume x 4 meter. When x equal to 4 meter, then we got value Vx is 3. Then when x equal to 16 meter, then we got Vx. Sorry. When x equal to 4, Vx equal to 0.75. When x equal to 16 meter, we got Vx equal to 0. Okay, this is for shear Vx from right section. Then this is for moment to find the moment x. Moment at x equal to 0. Then RA equal to 1 minus x over 16 times 4 minus mx equal to 0. So we got mx equal to 4 minus x over 4. To find the value mx, we assume x 4 meter and 16 meter. So when x equal to 4 meter, we got mx equal to 3 kilonewton meter. Then when x equal to 16 meter, we got mx equal to 0. Okay, now we draw the SFD from based on the value Vx and Mx that we got just now. So SFD from 0 between 4 meter, we got value negative 0.25. Then this is for to balance this point load. From the equation that we got just now, that 4 meter between 16 meter, this one we got the value 0.75. This one is 0, 0. And here also we got value negative 0.75. Okay, this is for SFD. And for the BMD, we draw based on the value that we got just now also. So for the x between 0 and 4 meter, we got the value here is 3 kilonewton meter. Then for x 4 meter between 16 meter, we got here is also 3 kilonewton meter, and this one is 0 kilonewton meter. Okay, that's all.
Okay, for question C, to determine the maximum positive shear that can be developed at point X for the beam due to concentration moving load 10 kN and uniform moving load at 4 kN per meter along the span. So, based on the SFD that we got from question B, we know this is the negative value and this is the positive. The question asks for the positive shear, so we only take the positive part like this. The length is 0.75 for point load. From question is 10 kN. We times with 0.75, this one is equal to 75 kN. For UDL, we calculate the area times by 4. So 1/2 times 0.75 times 12 meter times by 4 is equal to 18 kilonewton. The maximum is 75 plus 18 equal to, wait, I calculate first. 83 kilonewton. That's all. Okay, correction. This one we get 7.5. So this one 7.5 plus 18 is 25.5 kilonewton. Alright, thank you.
I will explain for between construction of for line and construction of shear building moment diagram. And what do you think? I think for we have different the shear force diagram is representing for magnitude and direction of the shearing force effective of structure element when we subject it to any type of static loading. For the influence line diagram for shear force representing the change of shear force magnitude and direction at given section of the structure element caused by a unit load placed at any point along its spin. So this is the difference between construction and reference line and construction shear building moment diagram. Thank you.
Okay.